Hi everybody, this is CS22M506. I'm here recording the first part of the assignment. So before we actually run anything, we need to disable ASLR. I've done that already. I'll now go over sol.py. This is the file that brings up GDB and inserts binary data into the file we're debugging. So when this starts, it first gets the address of the leak and there are a few debug logs. Address of the leak is the same as the address of the buffer here. This is what we want to overflow. And once we have the address of the buffer, we need to inject the shell code there. So for the first part of the assignment, we were shared the shell code. This is the shell code. So we get the L file from it, and from the L file we generate the instructions needed to bring up the shell, and that's stored in shellcode-raw file. So shellcode-raw file contains all the instructions needed to bring up the shell. Now in get shellcode function, that's what we're doing. Yeah. So we're reading the file shellcode-raw as bytes and returning the byte content. So we have the shellcode here. Right? Once we have the shellcode, the program then asks us for the total length of the data we're injecting into the buffer. So here we're injecting 112 bytes, 104 plus 8. 104 is 30 bytes of the shellcode and 74 bytes of nullpad, and 8 is the uh, P64 of the leak, which is packaging the address of the leak into 64-bit format. So that's 112 bytes. So we send 112 when the program asks us for the length. And then we actually send the data here. Another thing I've done here is I've added two breakpoints on line 42 and 44 of this file. It's because uh, when the first breakpoint on 42 will be hit when like before the contents are read into the buffer, and this is the last line of the function. So between these two breakpoints, we'll be able to compare the contents of the stack and if we have actually injected the data the way we want to, right? And we also continue till we reach the first breakpoint, and once we hit the first breakpoint, we inspect the contents of the stack. So all this is run automatically on when the file is run. Then I've set the binary as main. That's because I've already compiled this file using these flags and saved it as main. So I've already done this. Now let's see the attack in action. If I start it, yeah. So the stack has come up. Now we can, if you go to the other terminal, we'll be able to see the address of the leak. It is at DC20 because the first so many bytes will be the same. The last 4 bytes are what is important to us. So DC20. This is where the buffer is, and these are the first 90 bytes of the buffer. They're all null because that's how we've initialized it. And DCA88. So this is the return address of the function. This is what we want to overwrite. So we want to inject the shellcode here at DC20, right? Yeah, DC20, and uh, point DC88 to this memory location, right? So if I hit continue, we would have injected the data into the buffer and we can inspect the contents again. So now the second breakpoint is hit. This is the last line of the function. Now if we inspect the contents of the stack, we do in fact see that DC20 has the binary data for bringing up the shell here, right? 30 bytes of the binary data and so many bytes of nullpad. And after that, we see that uh, DC88 has the address of 7FFF06 BC 20, right, which is pointing to this. So now we have actually successfully injected the data and also pointed the return address to the data we've injected. Right. So if I hit continue now, the shell code should be brought up. Yeah, and we see that the program is actually executing bin dash. So bin dash is another way of bringing up bin sh. So we were successfully able to bring up the shell. Now if I hit close, it closes and it says the shell has been stopped, right? So we were successfully able to bring up the shell through this attack. Another thing I want to show is that bin dash is the same as bin sh. So if I inspect the contents of slash bin directory, we can see that sh is pointed to dash. So we've successfully brought up the shell. So as part of this assignment, the requirements were met. We've successfully brought up the shell and using the shell code given. Thank you.